Well, one of the cool experiments that I've done in physics is to illustrate the effect that different temperatures have on materials and the rapid transition from one temperature to another. So what you do is you take like a soda can and you fill it about half full with water. You set it on a hot plate until the water starts to boil. Now, once it starts to boil, you have to put a little bit of water on, half or less. Okay. Once it starts to boil, you then have to have like a bucket of ice water. And you take the can and you flip it over upside down into the bucket of ice water as fast as you can. And yeah, it crushes the can. If you get the temperatures
in a second,
if you get the temperatures really extreme, it will almost instantly crush the can. And when you pull it out of the water, it looks like more water is coming out than actually is, which is another part of that. I'm not sure how that works, but it looks like it pours for forever.
Probably.
Yeah, probably condensation. Cool. It's really cool. There's that one, and you can also cut a can in half using eddy currents from magnetism. There's an experiment that I just saw a couple weeks, like last week, in my Physics 270 class, where he took a soda can and he had this big machine that generated a pretty powerful magnetic field around a small circle. And he put the soda can in and turned it on, and it pretty much sliced the soda can in half by just crunching it really hard.
That's weird.
Yeah.
How does that?
Because the way that the induced current in it would work, the eddy currents generated would push it in different directions all the way towards the center of the can. So the reaction to magnetic field would be for the can to push inward really fast, which ends up tearing the can in half. Cool.
Yeah, that'll definitely make an effect. Now, the thing about that one is that works in a classroom. That won't work as well at home because you don't have that big thing. Yeah, that's why the school program's great. Like, okay, so a really useful use for infrared cameras, instead of hunting ghosts, is another demonstration of invisible light. You give kids an ice cube. So, of course, we have access to an infrared camera in our department. You give them a bucket of ice and just let them go wild, and they'll paint all over their faces with an ice cube because those parts of their face turn, dark blue. Yeah.
What are you measuring? Are you measuring their comprehension of the process that's going on, their comprehension of what's happened? Is that what you're...
We're looking to measure, what they've picked up about astronomy, and maybe attitudes towards science as well. See if we're changing their attitudes towards science. We actually had one of the fourth graders last semester raised his hand and said, during discussion time, he said, doesn't science make bad things like bombs? And this was a big question from a fourth grader. So we're hoping to change their attitudes, and if they're hearing bad stuff about science and scientists. Yeah.
Are they working as a group? And is that because they could do a group presentation? And you need a rubric to basically assess their level of critical thinking. But
I like that.
You could have them design and conduct experiments of their own.
Yeah.
Like do sort of miniature independent research.
Are you taking notes?
Should be. Mentally, I am, but yeah, that's not. Someone take notes for me. Oh, sweet. There we go. Yes.
Do you run into any issues with parents, like for permission to do certain things? Like I know if you're going to do astronomy type projects, you're obviously going to need them to come out at night. Have you ever run into, like you're saying, opening up their minds about the stereotypes of science? Do you run into that with the parents at all?
We haven't yet. Students are come into the program voluntarily. We open it up to the school and say we have about 15 slots. And so students, parents have to put their kids in the program. So there's a self-selecting already based on that. As far as getting them to come out at night, it depends on schedules and things like that. But we've had parents come and bring all the kids and just have a blast out there. So we haven't run into that yet. Yeah.
One thing that I want to say, with my nieces and nephews, we would do the experiments from Kitchen Science, from the Naked Scientists. Those are really great. A lot of them they're very easy.
Science?
Yeah,
Kitchen Science?
Okay.
Every once in a while there's one that's really hard to do, but they're usually very easy. And they have failures like them. But also, just as far as assessing them, I think that if you're going to do a series of experiments, since they always love to be one step ahead and figure out what's going on, just as far as them predicting, what the hypothesis might be of one experiment or what the different things could happen, that might be a good way to gauge, how well they understand it.
What kind of, you said that the people come to the thing voluntarily. What kind of spread do you get? Like, do you get more boys than girls? Do you get different age groups? I mean, have you done?
Well, we limit it to 3rd through 5th graders, and I wasn't there both semesters. I was there in the spring semester, and it was pretty even, boys and girls. Now, the boys tended to attach themselves to the male volunteers, and the girls tended to attach themselves to the female volunteers. But I think it was a pretty even split. And they were there for different reasons. That particular school had them write an essay as to why they wanted to be in the astronomy club, and some of them were, probably pushed by their parents. You can kind of tell, and some had had an interest in the subject to start with. Yeah. It's kind of small numbers still, but that would be,
That'd be interesting.
yeah. They were, we had a bunch 3rd and 5th graders. We had one 2nd grader who got in somehow. He was very wild. Adorable, but wild. Yeah. There's a hand back here? No? Yes? Yeah.
I want to know if Phil Plait used your recipe for comments on his show.
You know the answer to that. Yeah, the comment. I was very excited. So as we started to formalize our activities, because we're going to be using them every semester, so we wanted to write them down. But also they're available at the website for teachers to adapt for their own use. But yeah, Phil emailed me, says, "Hey, I saw your comet pictures. I could never get one of those to work right. So can we have your recipe?" So the recipe, if you saw a Bad Universe, the recipe he used was Dark Skies, Bright Kids recipe. So we were very excited about that. That was my friend Gail. My friend Gail's the one who actually wrote the recipe, so she gets all, all the kudos for that. But yeah, we just play, and us, the volunteers for the club are mostly, there's one professor who started the club, Kelsey Johnson. She's just a fantastic woman. And then there's a bunch of us, most of us, the volunteers are grad students, so we get to play with hands-on stuff. And for us, it's a way of rethinking about concepts that we learned long ago, and being able to teach them, and also goof around and not be stuck behind our computer terminal all day. So, yeah.
Is this in Charlottesville?
Yeah, this isn't. Yeah, in Albemarle County.
That's right, because I got 4 grandkids down there, so I don't know.
Oh, really? Really? What schools do they?
One just entered 2nd grade.
Okay.
The others are all. So
We've
they'll be
been
a little while, but they'll be interested.
We've been at Red Hill and Yancey so far. We're hoping to expand.
I'm not sure.
Okay. Yeah. Any other comments? Anyone else with educational experience could help with assessment? That question. Yeah.
I think that you're going to find that assessing critical thinking is, without using a test, it can be incredibly difficult. I mean, and designing, for example, rubrics and the levels, and what constitutes true critical thinking, it's a difficult process. But there are resources out there. I mean, there's several different websites. Criticalthinking.org is one that you might want to take a look at.
Yeah. The thing with assessment tools is you don't always know if you're assessing what you think you're assessing. And so to actually design something from college astronomy education, they had to go through all these hoops to design an assessment tool for astronomy concepts, and what they were testing wasn't quite what they thought they were testing. So when you design a test like that, you have to follow it up with interviews and things like that to make sure you know that you're testing the right thing. Yeah.
And I've actually found that I teach history, but I try to bring critical thinking into the classroom, and I've designed assessments that I think they're solid, and I think I'm really testing their knowledge of being able to critically analyze a source or something like that. But then every once in a while in class we're going over it, a student will address something that I missed, but that's critical thinking. They're sitting there critically thinking about my question and about my answer that I say is the correct answer, and hey, how can I have to reward that?
Right.
So it's an ongoing process.
It would be a little problematic, but recording the discussions, you'd have to get permission from the parents to do that. But there are key things that the kids might say in the discussion that shows that they're thinking those higher processes, perhaps. Because I think talking about the experiment would help me figure out what I'm looking at, and help the kids figure out maybe some of that memory in their heads.
Yeah, definitely. And we do, because I'm showing pictures of kids, we do have them sign for waivers for the parents. Yeah.
Interesting, though, on that note, of recording, depending on your state, as long as one, like I think in Maryland the rule is as long as one of the, if you're in a public setting, and one of the people knows that there's that you people recording it, and they're okay with it, and it can be the person who is
It's
recording
not.
it.
It's actually 2 in Maryland, and it's different when you have kids.
It's only a couple of states where it's
Because there was an issue with that where a kid recorded one of his teachers in class because they were proselytizing in class, and so they ran into legal trouble with that. I thought it was one.
It's
Oh,
2.
it's 2?
Yeah.
Okay.
Two parties.
2 parties consent state.
Maryland's wiretap laws are especially egregious.
Yeah, we go through, we have a form that the parents sign to see either it's okay or not okay. So we take pictures, we take, I put together a podcast, I have audio recordings of the kids, it's very amusing. We have video, but we just kind of we take all that stuff, but only the kids for whom their parents have signed off saying, yes, you can use it publicly, does it ever actually get used anywhere. So yeah, they do know that. It's funny the things they say. It's awesome.
Where can we find this podcast?
365 Days of Astronomy.
Okay.
Yeah, Google my name there, Dark Skies, Bright Kids, they'll come up. It's one of the 10-minute podcasts. They're very cute. So. Any other questions, comments? Oh, yeah.
You might have said this already, but did you ever find an example of somebody who came into the program who wasn't really interested, and at the end was like at least showed some improvement in terms of interest?
Yeah, a couple of the 5th grade girls last time, because their 5th grade's the last grade in that school before they move on to intermediate school, and they were just too cool for this stuff. And so they just didn't, their parents must have put them in the club. And by the end, I had one of them, you kind of have to figure out what their interests are. If they're not really interested in the activity, like, here's a pad, you want to draw something? Draw something. And so she started sketching what it might look like to get sucked into a black hole, because we happened to be talking about that day, not that she's morbid or anything. So yeah, especially reaching the... That's another thing going, huh? But yeah, especially with the 5th graders, they kind of think they're too cool for it, but either with physical activities or reaching them some other way.
Were there any plans to assess what changes their mind, or is that too much? I'd be interested in personally in knowing what if people are too cool for it in terms of, or not that we're trying to turn it, like, what changes their mind.
This semester we're trying like entrance interviews and exit interviews to see if we can kind of gauge that change over the semester. I missed it. It was last Friday. I had 2 days ago. I had a workshop, so I missed it. But yeah, they interviewed all the kids, and they did get it actually on video.
Has there ever been anyone that went the other direction, that came in, well, not necessarily excited about it, but came in thinking this might be okay, or came in, pushed into it, and then at the end thought completely against it, or like, oh, this is definitely not for me?
Not really. I didn't notice that personally, but yeah, I didn't notice that personally. You can usually find something to get them excited, even if it's just, we tried playing comet tags. So we have you be the comet, and you be the planet, and they ended up just running around and not caring anyway. But physical activity reaches some of the other kids. Yeah. Okay. So no other questions? You want to move on to the next speaker? Yeah? Thank you.